Hello everyone. In this video, we will define few basic notions in probability. First, let's start what is probability itself. Probability is study of experiments with non-deterministic outcomes. Well, when I say experiment, it means that you have a procedure, you do it, and then the result, you measure something in that experiment. In some experiments, your result is fixed. Everyone who does this experiment will get the same thing. No one will get different thing. But sometimes it will depend it will depend, and it won't be possible to determine exactly what will happen. That's where this non-deterministic comes in. For example, these experiments we see every day. So some of the examples that we will study here, and we will go over these ones again and again, are these ones. For example, when you toss a coin or roll a die, yes, roll a die, you know that the number between 1 and 6 will come up, but no one for sure can tell us what is that number. So that's the non-deterministic nature. Or when you roll 2 die and add up the numbers which come up, and then that is another thing. So it can be any number between 2 to 12. Yes. And draw a card from standard card deck, and then toss a coin, and if it is, let's see if it is head or tail, toss a coin 4 times, and all these things. Yes. And each time you do one of these experiments, a result you will see. Those results are called outcomes. For example, for the first one, outcomes are any number between 1 to 6, yes. For the second one, outcomes are, adding two numbers which are between 1 and 6, then the sum can be 2, 3, up to 12, yes. Not 13, 1 is not there. The outcomes are these ones. And draw a card. Any card will be one outcome here. This other one, the tossing a coin will be head or tail. The other one, the outcomes will be, for example, head. I'm doing 4 times. Or, for example, head, tail, and so on. All the possible things. Okay? And, that is what we have for the experiment, what we mean by experiment, and what we mean by outcomes. But when you want to study such an experiment, the first thing that you have to fix, it's called sample space. So this is the definition. A sample space for an experiment is a partition of all possible results or outcomes of that experiment. We usually denote that by S. Let us do with some more details here. So we usually denote it by S. So it will have S is sets like A, B, and so on. But when I say partition, what I am exactly looking for are these two properties. First of all, by partition, we mean you have to look for these two things. First of all, it is complete. What does it mean being complete? It means that every possible outcome must be included in one of the elements of S. Every outcome is included in one of the elements. And the second thing that you have to look for is that the elements of S are mutually exclusive. Or mutually exclusive is a fancy way of saying that the intersection of any two of them are empty set. That is, the intersection of any two members of S is empty. Is the empty set. Let me write it completely there. So completeness and having mutually exclusive elements are two properties which define a sample space. There are a few things that you have to note here, that for an experiment we may have more than one sample space. That's why we say a sample space. And the second thing is that, well, the entries that you see here, these might be set of outcomes, but when we put them in S, we call them sample points. So we need to fix a sample space and then go on work with probability. And sample space, it must be complete. It should include all the possible outcomes, and its entries or elements must be mutually exclusive. In other words, it must be a partition of all possible outcomes of the experiment. Let's see this in some examples. Consider the experiment that roll 2 dice and observe what is the sum of the numbers. Which of the following set would be a sample space for this experiment? So we are trying to check completeness and mutually exclusiveness. Yes. So here, let's just start with S1. So the sum being 2, the sum being 3, the sum being 4 up to 12. First of all, it is complete because, well, if you add of two numbers from dice roll, so you get 1 1, it's the minimum. You 1 2 1 3, you get up to 12, and that all the other numbers you add these two from these two dice roll, it will add up to a number between 2 and 4. So addition of 2 will be a number between and including 2 and 12 inclusive. So that's clear. On the other hand, the elements are mutually exclusive. If sum of two things, 2 dice add up to 3, it won't add up to any number else. Obviously, it is or it has mutually exclusive elements. So that means that yes, S1 is a sample space. How about S2? Okay, S2. Well, sums of two numbers, well, it's a number, yeah, 2 to 12. It is either even number 2, 4, 6 up to, well, even numbers up to 12, or it will be odd number. Obviously, this is complete and mutually exclusive. If sum of two things is odd, it cannot be even. So then I will go and write that is exclusive. So I don't put anything there. S3. So first thing you see that, okay, the sum is less than 8 or the sum is bigger than 5. So S3 is complete because you add two numbers and it will be a number either less than 8 or bigger than 5. Yes, is complete. But it's not, it doesn't have mutually exclusive elements, but the elements or sample points have an intersection. And what is the intersection? So the sum is equal to 6 or equal to 7 are in the intersection. In other words, the outcomes which are the sums of, well, for example, 1 and 5 and 2 and 5, they will add up to 7 and 6, is in both sum is less than 8 and sum is bigger than 5. So that means that, okay, this doesn't have mutually exclusive and it's not a sample space. Sum is divisible by 3, sum is divisible by 2. Well, that is neither complete nor have exclusive or mutually exclusive elements. Why is that so? It's not complete because, for example, if sum is 5, it is not included in either two elements of the set. 5 is not divisible by 3, 5 is not divisible by 2. On the other hand, a number like 6 is divisible by both 3 and 2, and that's why it's not mutually exclusive. These two elements are not mutually exclusive. So it's not a sample space. How about sum is even and sum is bigger than 2? So obviously here, so let me just make a little bit more space here. Obviously here, we are again getting not complete because, for example, a number like a 3 is not included. A sum being equal to 3 is not included. And actually it's not mutually exclusive because as a number like 8 is included in both. So it is not. So while checking this sums sample spaces, you have to check two things: completeness and mutually exclusiveness of its elements. Okay. One last notion that we have to cover here is event. When you fix a set, a sample space, then any subset of the sample space is going to be called an event. An event is a subset of the fixed sample space. Well, for example, in that case of the above case, so in the case of two roll or two dice roll, I should have written two dice roll, we had sums between 2 and 12 would come, something like 2, 4, and 10 is an event. For which sample space? For S1. Remember, S1 was the list of all things. And well, two sample space, another definition which we are just using now here a lot. It's two events. Two events are called mutually exclusive if their intersection is the empty set. That's exactly what we have used. So when we study the properties, this word we will use several times, properties of probability. Okay, so let's finish this video with one example. John, Fred, coin toss. They toss a coin, define a sample space for this experiment and find subsets corresponding to these events. So here, the sample space, the simplest one that you can do, list all outcomes. You don't need to do anything. So here, the first one is for Joanne and the second one for Fred. So head, 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 tail, tail, head, and tail, tail. That's a sample space. A sample space, you can have different sample spaces. And then, well, both of them are having same result. So the event, both of them have the same result. This is, well, either both get edge or tail. Yeah. And the second one, the Joan gets head. So we are considering the first one is for Joan, the second one is for Fred. That's my convention here. So for the second one, the event, let's call it F, is Joan is getting head. So head, tail, head, Fred's also getting edge. And that's what we have. So here there are at least three important notions that you have to know: outcomes, sample spaces, and events. We specifically will focus on sample spaces and events in the next section or next unit.